I'm Professor Zavala, and I am going to talk to you about this gravity formula in greater detail. I want to go through this problem and unpack it so that we have better understanding of what is happening here. So I'll start off by reading it with you. A rock is thrown upward with a velocity of 20 meters per second from the top of a 24-meter high cliff, and it misses the cliff on the way back down. When will the rock be 10 meters from ground level? Round your answer to 2 decimal places. The first thing I want to do is start off by visiting with you about this formula. H stands for height. So this H is our height. Equals negative 1/2 times G, where G is our gravity. Notice we have 32 feet per second or 9.8 meters per second squared. We'll know which unit to use by the reading. In our reading, you'll see all the units are in meters. This tells me that I'm going to use 9.8. T stands for time. Notice the question is asking, when will the rock be 10 meters from the ground? When is referring to time. Now here's this variable that gets some of us confused. This v sub 0. We'll call it the initial velocity. The initial velocity is going to be given to us in the reading. And that comes from this part here. A rock is thrown upward with a velocity of 20 meters per second. This is the initial velocity. Times t for time, plus the initial height, or h sub 0. This is given to us top of a 24-meter high cliff. Let's put all of this into the formula, and we will get the height equals negative 1/2 times 9.8 times t squared plus 20 times t plus 24. We need to get to this point here. This is just substituting our values into the equation. Now we want to know when the rock will be 10 meters from ground level. This 10 meters from ground level has to be our height. So I'm going to set the equation equal to 10 as the height, and I'm also going to multiply negative 1/2 times 9.8. That'll give me negative 4.9 t squared plus 20t plus 24. Generally, we want to set this equation equal to 0. So I'll subtract 10 on both sides, and this will give me 0 equals negative 4.9 t squared plus 20t plus 14. And this is the equation of interest. So far, all we've done was create an equation. Let's see what this equation looks like when graphed. Graphing the equation gives us an upside down parabola, and as you can see, the peak of the parabola happens here and it goes back down. So this is the height the projectile takes. the projectile goes up, hits the maximum height, and then turns back down and goes back down. Let's not forget what's given to us, the initial height. Our initial height is 24 meters high, which happens to take place about right here. So we have somewhat of a cliff. Here is a rough picture of what a cliff might look like 24 meters high. Now we have somebody throwing a rock with an initial velocity of 24 meters per second squared. And if you look real closely, you can see there's somebody standing on this cliff and the rock is following this height function. What we are asked to do is find out when the rock will be 10 meters above the ground. At 10 meters above the ground, it looks like our rock is going to be about right here. And if I follow this down, it looks like it's about 4.5 seconds. If I zoom in a little bit closer, you can see that the red line, the graph, does not intersect right here at this point. It's going to be close, but it does not intersect. And this is what we are looking at. So roughly, we can say it's about 4.5 seconds is the time in which it'll take the rock to be 10 meters above the ground. But let's go into solving this algebraically. Our formula is 0 equals negative 4.9 t squared plus 20t plus 14. This is a quadratic equation, and we can use the quadratic formula to solve it. I'll identify my A. My A is negative 4.9. My B is 20, and my C is 14. Substituting these values into the quadratic formula, T equals negative 20 plus or minus the square root of 20 squared minus 4 times negative 4.9 times C, which is 14, all over 2 times negative 4.9. Getting this into our calculator, we will arrive at approximately 4.69 seconds. Recall that according to our picture, it looked like it was 4.5, but it's actually a little bit beyond 4.5. If I were to follow that down to here, that would take me to 4.69. Hopefully with the graph and the picture that goes along with this problem, you have a better idea of what's happening versus just trying to use the equation to come up with some answer. After watching this video, reach out to me if you have any questions, or if you have any comments, you can list them below.